Hello, Trig students. This is lesson 53, review unit multipliers and angular velocity. We're going to quickly review angular velocity versus linear velocity by thinking about a 90-degree angle. So I'm just going to sketch that here in my notes. I'm going to make a 90-degree angle, and we know that this is 90 degrees. So if we have a question on angular velocity for perhaps somebody traveling through that 90 degrees, their angular velocity is going to involve 90 degrees. But if we talk about linear velocity and we're comparing the path of the orange versus the blue path, even though it's still 90 degrees, the linear velocity for which that blue path travels is going to be much greater, okay, because their distance across there is much greater, and the rate is going to change for that as well. So linear velocity is going to involve more than just the angle. Okay, so we're going to go to some of our questions for our notes. And the first one is just reviewing when we convert between different units. So let me pull this up. We're going to convert 20 miles per hour converted over to meters per second. Okay, so I start by writing down the initial rate, which is 20 miles for 1 hour. And I'm going to convert miles over to meters. So that's the first thing I'm going to do. So I'm going to change miles over to feet, then inches, then centimeters, then meters. And I know that 5,280 feet is 1 mile. And then from feet, I'm going to go to inches. 12 inches makes 1 foot. Okay, and then from inches, I go to centimeters. 2.54 centimeters equates to 1 inch. And then the last step on this one is going from centimeters to meters. I know that 1 meter makes up 100 centimeters. Okay, then I'm going to go back and change units or cancel out units that I've used so far. So right now I have meters on top and I have hours in my denominator. I'm going to convert my hours over to seconds. Okay, so I have to change hours to seconds. Right now, hours is in my denominator, so when I cancel it, I put it in the numerator, convert it over to minutes, and then from minutes, I convert over to seconds. And I'm going to change or cancel out my units that I've used there, so hours cancel, minutes cancel, and I have seconds left. Okay, then on my calculator, I'm going to have to multiply 20, 5280, 12, 2.54. All of that divided by 100, divide by 60, divide by 60. Okay, and so what I get on my first run through, my numerator is 3,218,688. And my denominator is 360,000. And then you may not have had that step in between. You may have gone straight to this decimal answer. So my final answer, I got 8.9408, and that was in meters per second. So final answer. Question B. We're comparing the wheel on a Mercedes with a radius of 14 inches, and it's revolving at 40 revolutions per minute. How fast is the Mercedes moving in miles per hour? Okay, so this first thing I'm going to do on here, step 1, is I'm going to convert revolutions per minute, and I'm going to convert that over to radians per minute. Okay, so the question gives us 40 revolutions per minute. So I'm going to write that as 40 rev over 1 minute. And then to convert that, I know that I need to move to radians. 2 pi radians, that's 1 full circle around, that is equivalent to 1 revolution. Okay, so now when I go to cancel units, revolutions cancel, and I'm going to have radians on top. So I have 40 times 2 times pi. For right now, I'm going to keep that as pi form. So I get 80 pi radians per minute. All right, and then step 2 is find the linear velocity. Okay, so to do that, I'm going to use the formula V equals RW. Okay, that is the velocity is equal to the radius times the angular velocity. So the radius given is 14 inches. And then remember that we just worked on our angular velocity, and that is 80 pi radians per minute. Okay, and then once we have that, we're ready for step 3. And that is where we have to convert that we just got into miles per hour. Okay, and that was given to us in the question that we needed miles per hour. So I take the 14 inches and the 80 pi radians per minute. So now we have 14 times 80 pi. And we also still have our inches over our minutes. Okay, now you'll notice that I just let radians go away. We had talked about how radians and degrees, sometimes we're able to just let those come in or go as we need. So I am now ready to convert. I'm going to do my minutes converted over to hours. So if I have minutes on bottom, that means I have to cancel on top 60 minutes for 1 hour. And then I'm also needing to convert to miles, and right now I have inches. So I'm first going to convert to feet. 1 foot converts with 12 inches. And then 1 mile converts with 5,280 feet. Okay, so those are all the numbers that I need to convert. I'm just going to squish this on here. And I would plug in all of that into my calculator, including the pi button. And then my result was 3.33 miles per hour. All right, that was question B. Now we're going to go over here to question C. Working with a BMW this time, it has wheels 30 inches in diameter, and it's traveling 40 miles per hour. I need to know the angular velocity of the wheels in revolutions per second. So we're almost working backwards from what the previous question was. Okay, so the first thing I'm going to do is just have a quick reminder that when we're looking for angular velocity, it is velocity divided by the radius. Okay, so pulling from the question, the velocity that is provided is 40 miles per hour. And then the radius, don't be tricked by it. It's not 30, it's actually 15 inches because it was given to us as a diameter. Okay, and then if I rewrite this cleaned up a little bit, I have 40 miles over 15 inches times hours. And I would like to go ahead and get miles and inches on the same unit. So it's always better to convert down from the bigger unit. That means we're going to convert from the miles down to inches. So I first transfer to feet per mile, and then I would transfer to inches per feet. And I go back through and cancel out units. So I have miles cancel, feet cancel, and then inches cancel. So right now all I have is the hours on bottom, okay? And we are going to be able to stick radians back in here at this point. So let's see what we have. Simplified, I have multiplying a whole bunch of stuff together. Looks like I have 168,960 radians per hour. And then as my final step, I'm going to convert this to revolutions per second. Okay, because that was in the question that we need to convert over to revolutions per second. So let me set it up as, let me just back up here and write this nicer. This was radians per hour. And now I'm just going to convert it over to revolutions per second. So 1 revolution is basically the same as 2 pi radian. It goes all the way around 1 time. And then hours converted over to minutes. And then minutes converted over to seconds. Canceling out any units. Hours cancel, minutes cancel. What I'm left with is revolutions per second. So now I'm just going to grab my calculator, plug in a bunch of those numbers. And my final answer I get is 7.47 revolutions per second. All right. Now we're going to pull some from the homework. Let's go here to question 6 to start with. And it's not like one that we've had. Okay, so this question 6 is actually converting over francs and dollars. So Kelly is converting 2,800 francs to dollars at an exchange rate of 350 francs to the dollar. Okay, so if I write that out, we're starting off with 2,800 francs, and we're converting over to dollars. And the unit rate for that is $1 is equivalent to 350 francs. Okay, so that means that my unit of francs cancels, and I have to multiply across and then divide by 350, and I end up with $8. All right, then the second part of the question. Then he went to another country and converted back to francs at 400 francs to the dollar. So now I have $8, and I have to convert it back, and I get 400 francs per $1. Okay, so my dollars cancel, and I'm left with francs. I end up with 3,200 francs. What is the profit? Well, I'm going to take my final amount of francs and subtract it from my original amount of francs in order to find the profit. So my profit is going to equal 400 francs. All right, and then let's go ahead and try number 7 together. And question 7 is converting 50 miles per hour to centimeters per minute. So we're starting with 50 miles per hour, and we're converting over to centimeters per minute. I start by writing out 50 miles over 1 hour, and I'm going to convert first my miles, my distance, and then I'll convert over my time. So for every 1 mile, that's 5,280 feet. Feet converted over to inches. I now have 12 inches for 1 foot. And then converting that over to centimeters, I get 2.54 centimeters for every 1 inch. Let me cancel what I have so far. Miles cancel, feet cancel, inches cancel. I have centimeters on top. I need to now convert over my minutes. And I can do that by canceling 1 hour on top with 60 minutes on bottom. Okay, so my hours are now canceling. Now I'm going to go through and multiply all the numbers that are left. And it looks like I'm only dividing by 60 on bottom. So I end up with 134,112 centimeters per minute. And that's my final answer there. All right, and I'm going to stop there and have the rest be up to you. Good luck.